that they're going to take it today. So you're going to see it later.
Of course.
Of course. All right. Let's go through a couple notes here. Let's see.
You want to take over?
Not really.
That was a scar. She was happy. I was trying to lift her off my lap, but it's fine. My cat was really bad.
Okay, today what we're going to do is we're going to take a few notes on this chapter 6:1. Get that to go away. There we go. All right. And then we're going to do a little activity today. So hopefully this makes sense. I think it's pretty easy. I'll only have you for about a half hour or so. So this will get you to move around a little bit so you're not just stuck in the same spot. I know it's early in the morning, but it'll get you to move around. All right, we're in section 6:1. We're talking about quads. Remember, quads are four-sided figures. Now, the goal in the first section wasn't just to talk about, the quadrilaterals. They did introduce them, don't get me wrong, but it was to introduce a couple of properties that apply to any type of polygon whatsoever. So the first theorem we had yesterday, if you were here, the first theorem was this one. It was 6:1. It dealt with the sum of the interior angles of any polygon. The polygon had to be convex, so it couldn't have a little cave on it. Had to be convex, and it could be any number of sides. So they call it n-sided. N-sided, that means any number of sides. So it could be, a quad, which has 4 sides, or it could be up to, I think one of the examples one of my classes used was 84gon. That's the number they picked for some reason. But anyways, the key words here were these words. You had to know that these were the ones that applied. So we talked about, the sum means to add. You're going to be adding all the interior angles together. If it's n-sided, and that's the n is the number of sides that you have, and that's the same as the number of angles on the inside. This is the formula that we had. Okay, so one of the examples was, you could pick any number of walls. So one of the examples I think I used yesterday was like a 5-sided figure. You'd plug 5 in, you'd subtract 2, and that would give you a number here, and then you take that times 180. And that would tell you what all the angles in the inside have to add up to be. It's a one set number every single time. Doesn't matter if the picture's regular or not. Now, if the picture's regular, that means all the angles are the same. So if you know what all the angles add up to be, you can divide by how many angles there are. So, if it was a 5-sided figure, you go 5 minus 2, which is 3. 3 times 180 is 540. And then you can take 540 and divide by how many angles there are, which there would be 5 on a 5-sided figure, and it would give you like 108 for each angle, if they're all the same angles. But again, if they're all just random, you can figure out what they all add up to be. So that's kind of useful. Okay, and I'll show you an example of that later, later today, like what we could potentially use that for in the later sections. Why would this be important? Now, this is called the interior angle theorem. That was the first one we did yesterday. So if you were gone, that's when we did. Before we move on, does anyone still need that? I don't know what we had written down yesterday. We had that one for sure, correct? Okay. Okay, is everyone good? Now, if you haven't already, do have that formula written down. You're going to need that for your little station you're in. Okay, second theorem. Now, does anyone need to go back? Sorry. Everyone has it. Okay, second theorem. Was some of the exterior angles. Now we talked about this yesterday. Exterior is the most commonly mislabeled angles on a picture. Exterior angles, when you draw a picture, an exterior angle. Let's see, we'll go to the Pentagon here. Exterior angles are not just this outside. It's not the whole outside. That's what most people think. How you find an exterior angle, you can either go clockwise or counterclockwise. I usually go clockwise. And you extend the wall straight. That's an exterior angle. Then you go clockwise, you extend this wall straight. There's an exterior. Go clockwise, extend it straight. Turn clockwise, and then turn clockwise. Okay, and it kind of looks like a saw blade. That's basically the image I have in my head of it. You could go counterclockwise. That was a question I had earlier yesterday. But if you choose to go counterclockwise, you have to go counterclockwise the whole time. You can't mix and match. What I mean by that is you can't simply do this. So you start here and you go counterclockwise on this one. You go this direction. So you open up diagonally, and then suddenly you choose to go the other direction for some reason. This won't give you the right angle numbers now. So you have to go one direction the whole entire time. So if you go clockwise, you have to stick with clockwise the whole time. Keep that in mind, okay? Questions at all about how to do that type of problem? Okay, now, I know technically, like on this picture that I've drawn, going the other direction for one probably wouldn't make a big difference because they're going to add up anyways. But on a certain other type of picture, it definitely could, depend if there's more lines on the inside or not. But it's not a big deal. I know that some people are like, well, Ward, wouldn't it give you the same angle? In certain cases, yes, it would. Okay, depends on how many diagonals they've drawn. Now, the new thing today, and oh, by the way, this is called the exterior angle theorem, and they always add up to be 360 on the outside. That was something we talked about yesterday. It's not even a formula, it's just 360. Doesn't matter if it's a pentagon, if it's an octagon, if it's an 84gon, that was something that somebody used yesterday. They always add up to be 360. Now, if this picture is regular, obviously my picture is not, but let's say it was regular, where all the walls and all the angles are the same. You could actually figure out what each one of these are by themselves. Okay, because we know what they add up to be. But to find what each one is separately, you could divide by how many angles there are on the outside. So if it's a 5-sided figure, there's 5 angles on the outside, you could divide this by 5. And you can figure out what each one had to be. Okay, questions about that type of problem now? Okay, what is 36 divided by 5? Is that 52? Something like that? No, 72? 72? Sorry, 72. All right, questions on the two theorems we've had. This one's probably far the easiest, but most of the time what they always ask for is like one exterior, if it's regular. All right, the new one today. I did say we had one more theorem in this chapter, we had 3. But it's an extra one. It's not actually a theorem number, it's just a property that they have in the side notes of your textbook. Okay? It discusses the number of diagonals, the sum of the diagonals in a picture. So we got to talk about that. So the sum of the diagonals of an n-sided convex polygon. Now, one of the key words we have to talk about here is what a diagonal is in the first place. I think I hinted at it yesterday, but I do need to discuss that. The number of diagonals, and it's an extra property, it's just off the side note, but it is important. It actually explains, the diagonals actually do explain why some of these properties work, especially those first ones. But this is the formula that you have here. I know it's going to seem a little weird. It's n times n minus 3, and then you divide by 2. And this gives you how many diagonals total are in a picture. Unique diagonals. There should actually be some of the unique diagonals, but it's not repeating them. I'll explain here in a minute. This is the formula you need to have written down somewhere in your notes. Again, this property is just to help us find the number of diagonals. There's not really a theorem number that goes with it. They just give it as an extra property, but it is important. Okay, let's talk about what a diagonal is. I'm going to go to the pentagon that I had earlier. Okay, so here's my pentagon. A diagonal is when you choose one of the vertices. So you choose one of the vertices, and then you draw a line across the picture through the interior that connects to a vertex that's not already connected to. So like this vertex is actually connected to the top and this bottom left corner. But a diagonal would be going across the picture this way. That's a diagonal, that's 1. Then I could go down to this one, there's 2. And I would keep going. Now on the first theorem we did, this is the picture I had drawn. This explains why the first theorem works, 6-1. Because when you draw the diagonals from one vertex, it actually separates this picture into 3 triangles. That's why when you do the interior angle formula for a pentagon, you take 5 minus 2, because there's 5 walls, and you get 3 because there's 3 triangles, and triangles are worth 180. That's what it does for that first theorem. But what we need is how many total diagonals there are altogether. So right now I already have 2 drawn, so there's no more I can draw from that dot. So I go to the next dot, I can draw 3, 4. I go to the next dot, I already have that one drawn, that's 5. And then I go to that one's already drawn, go over here, those are drawn. So there was 5 diagonals total. And yes, they always make a star-like pattern when you draw through the middle. That's how it always works. It's a 5-sided star. But again, how it works, like what you're supposed to do is take the number of walls times the number of walls minus 3, and then you divide that whole answer by 2, and that should give you how many diagonals there are total without having to draw them all. So this is what, 5 times 2, because 5 minus 3 is 2, and then we divide by 2, so that's 10 divided by 2, which is 5. The same. Now, the reason why it's 5 minus 3 times 5, and then you divide by 2, is because what this is actually doing is this number here in the little parenthesis is how many diagonals you're actually drawing from each dot. That's what this number is giving you. So that's why there's a 2 here. From each vertex, you're drawing 2 actual lines. So that's what this first number is. The bottom number means they're going to eventually start repeating over and over and over. So when I started going to the next dots and drawing them again, eventually they would start repeating. And it would actually, that's why you divide by 2. They actually doubled. There's actually, when you actually draw all the diagonals from every dot, you'd actually have twice as many as what you need originally to get the unique line, so you divide by 2. That works in every picture. It doesn't matter if it's a pentagon, 5-sided figure, if it's an 84-gon. If you actually draw all the diagonals from each vertex, you'd actually have double the amount, so you have to divide by 2 to get the unique number, so that you're only counting the lines once when you draw. Questions? Again, this saves you from drawing them. Now, when you draw all the diagonals, obviously it makes a star-like pattern. It breaks the picture up in a bunch of smaller triangles or pentagons or other shapes. But the idea is that what we're going to eventually use this for when we start drawing diagonals is so that we can break them into triangles and we can find area of these pictures. Because if you have a bunch of smaller triangles, you can find area of all the triangles separately. And that's something we're going to eventually do later. Okay, questions? All right, so we're going to get started on this activity. Well, the activity is pretty straightforward. You guys are in a little pod. I'm going to provide your group with a couple pictures, either pictures or words, and you're going to have to do a very specific direction for your problem. Like number 1, you're going to find what all the interior angles add up to be for your picture. Or you're going to find the number of diagonals in the picture. Or, without drawing by the way, on the picture I give you. Or find the exterior angles, what they add up to be. Or find one of them if it's regular. So you got to read the directions very specifically. Your group will need a calculator. So if you have one, take one out. If you don't, you need to go to the back to grab one. I have one missing, so I think someone borrowed it yesterday, so I don't know if it was you guys or it was my last period. Okay, everyone's ready to go? I'm going to move the camera here. All right. So, group number 1, there you go. Group number 2, there you go. Now remember, don't. Group number 3, group number 4, and group number 5. All right. Okay, now, each group has their own directions. Now, I do not want you to draw or write on the little piece of paper or draw on that little envelope, however you want to pronounce it. All I want you to do is answer the question for those. So you'll need a separate sheet of paper. Your group can just use one piece if you want. But I'd prefer that everyone has their own, so that way you can kind of work on your own paper if you need to. You need to open up the envelope. There's a couple things on the inside. Some of you have 3 pictures. Some of you only have a couple words. Some of you have a challenge question, really. And I want to see how well you can do. It's kind of a little trial and error today. So, for the first couple groups, like this group up here, they had to find the interior angles all added together. And then they have to find, if they read the instructions, they have to find one of them, if it's regular. Okay, that group over there, I think, what do you guys have, diagonals? Diagonals? Third group, what do you guys have, exterior angles? No, interior angles all added together, the sum of all. Okay, third group, you guys have one exterior, single exterior angle. So if you know they all have to be by one. And the last group has a challenge question. They have to see if they can figure it out. Okay, you have to do both. You have to do both. So like each group usually has 2 or 3, and then talk it over. And I'll cycle through the formulas on the board for you.
writing it off your paper, you already have it down.
You
get it? I get it. Yeah, each one will go like 120 equals 540. Okay. That divided very well.
What's that asking?
Okay, so.
Does only one of us need the answers?
Yeah, technically you only need one piece of paper, but
Yeah, that's supposed to be a 0.
If your angle has to be more than 90.
Or 2.5.
interior angles,
Yeah.
that's your 180 times
Just 135?
n minus 2.
Oh, that's very much
That
better,
one.
nicely. Oh, that's easy.
And it's 9,000.
Minus 2. Every time we always get the and then like
Wait, Mr. Oh, interior angles. After I'm done, do I have to like divide the?
Once you find one of them,
So.
then you do that. But I think you just have to find what they all have.
1260.
What's the new one?
I don't know, it's like he's going to play for and like they ask for his Snapchat. So like
There's that one right there.
them, so I like say Maddie, but yeah, we know the words. Like he knows the word like
Wait, this is.
the whole French group is.
Yeah, no, I got it. Let's get done. They keep going. We're gonna get close to the right. If you can get on the last card
Every time we go to
now,
trust
we'll
me,
go
I always try to.
down.
We don't ever talk to him. We're
Yeah,
just like walking
it
around and
is.
we say what.
You know what? You messed me up. Done that.
It's just I can't get over how little he is. How little he's like 1,260.
Yeah, I'll give you another minute or two to try to figure it out. If you have questions, don't be afraid to ask. Remember, you gotta use the formulas that we have. The formulas are up here.
So that's it. Let's try. Well, now you can't back it down. Like,
No, I can.
Is that what it is? Oh. I see it. It's a policeman. You're right.
Try. So,
So that's fine. When you're
I don't know. Farther than you stayed up. You didn't have more cards. You didn't have non-flyers. I could have taken their cards. You know what? I could have.
Oxygon? Not an oxygon. No. Can that be shaded oxygon? Because I'm down. I know. You lost an item. Make a wish. I wish you never had. I wish you like Play-Doh again. My house is just. Oh. So you're below it onto me. That's fine. Oh no, that's just.
Some people.
All gone.
Oh, there it is.
I'm really just defeating the purpose of me drawing this because you can't even see the lines now, but it's fine. Thank you.
Okay, you guys good? All right, let's stand up. Rotate to your next group. So if you're at 4, you're going to go to 5. 5, go to 6. Or sorry, 5, go to 1. 1, go to 2, 2, 3, 3, 4. It should go in kind of a little S shape.
Are you mad about that?
Okay, leave your little cards where they're at.
What? When you did that, I did 2.
I thought we started.
No, 5, go to 1. Oh, one, sorry. There's no six.
Well, that's no fun.
Okay.
Okay.
You're a vet.
Find the measure of one interior angle on each polygon. Round answer. Tenth if necessary.
Wait, I was just trying to say.
So now let's find the polygon.
I know it's pretty nice.
Perfect, because I'm gonna learn that way. Which one do you want to do first? Do that one. Do one first.
Hey guys.
23. Nope. Divided by 2. I got that. That's the formula.
Probably.
Remember, read the directions. If it says one specific angle, remember you have to divide by how many angles there are. If it says just find the sum of all of them, then you know how to do that. The formulas are rotating on the board. You should be able to see them up here.
Yes.
So it'll be 108.
230.
Yeah, so the round the nearest 10th. I'm done.
Are you kidding me?
Do that. How much?
8. What does regular quadrilateral? That means 4.
Yeah.
Duh. Okay.
That was.
Spider-Man card?
Right.
Wait a minute, what are you guys doing? Crazy. You got
Want to get it?
Then bring it back for the next class.
Class here down, so I was like, what? Word love Spider-Man, I don't know. Either your kid does, one
My
like
son's
that.
obsessed
Wait, regular Spider-Man or Venom?
with it. Regular Spider-Man.
Okay.
He hasn't seen Venom yet. He knows Venom, but he hasn't seen it.
What one? Hey,
It's just 360.
times the 360 by.
Fine.
Times the thing.
Multiply.
4.
Multiply. You want to answer, you say times. I should know. I say it all the time.
Dude.
Whatever.
We don't know the We divide. We divide.
I should know. You used to with the after you say times. You still do. Oh, it's freshman year.
Can't read your big signals.
What is? Is it? Plus 6? What's that mean?
It's all the outside added together.
What? Wait,
So we have to draw 23 down.
Shouldn't have to drop you number.
No, you Plus 6. What do I do? 32.
So I got ready. I'm a 40.
Minus what do I know? I was doing fine with the divided by 8. Oh my gosh.
Okay, I'll give you about another minute or so.
Can you help us with this one? We're not catching on.
You can find one experience.
Got it.
Okay. You know what they all add up to?
No.
Yeah. They all have to.
16.
All exterior angles have to be 360.
Pointed
All you have to do is find one of them.
Okay.
If you know what they all add up to.
Alright, one other problem.
Something like that.
Yep.
360. That's what I said at first. That's what I told us to do. Okay, so 10
Divide.
10 is
Oh, I'm the one that's struggling in this class.
11. I'm at
I'm the one. I'm supposed to be struggling in this class.
What are those?
Not the other way around.
360 divided by
Okay.
minus 6, 5, 2, 1.
Are we good?
It takes a
No.
minute.
No.
He doesn't care.
No. Divided by 9. Okay, 90. Let's go.
Ladies, you good?
Yeah.
Okay, good?
Yeah.
Stand up, move to your next group. 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 1.
Solid.
Solid.
Lift it around one.
On the diagonal, some will be polygon, so all work just by results.
Hey, what?
But
On the diagonal. If one interior angle of each polygon, run your answer to the nearest 10 if necessary.
So would that be using
it must be
maybe
it must be done where it like divided
Yup,
first.
there you go, buddy.
here's that?
What's the question? Try to measure one interior angle of each polygon.
So,
Okay, well, let me guess that.
Oh, you're doing this now.
Yeah, I was like,
Probably
what?
I'm Luke. No, I don't.
This will probably be one of your last groups.
Solid.
potentially.
No, we all think.
Oh, yeah, we need to go.
I know you got like a couple more, but this will be the last one.
Aw, come on.
I'll do the one.
Okay, well, do number 3 and all
1,000 maybe on this one. Probably.
We're trying to find a single angle, so you take the 1,080 divided by 6.
So when your group finally has their final results, what I'd like you to do, place your numbers, your pictures, your directions back in the yellow envelope. And then we're gonna move back eventually. Go back to your original spots here in a minute. Remember, just have these on, a single sheet of paper. I prefer multiple, but if it's on single, it's fine. It's not a big deal because you're working in a group, so.
Should I try and make it in that trash can? I don't think I'd make it.
Where's this Johnny's in?
Give me
Switch these two.
tomorrow, man.
I need to get this.
You're on camera.
it's in there. It's over there.
No.
Formula.
No throwing things in class.
Okay, hey, place your directions back in the envelope. You need to move back to your original spot.
Slotted.
Try to remember what spot you're at today. So, right where you left off today, try to remember
I will
that.
swat you.
Okay, let's try to put my cards back on the desk. Where's that fourth card?
I don't know. Jeez, Nick.
Okay, place your directions back in the, back in the envelopes, please. I'm gonna take my envelope. Alright, tomorrow we'll continue.